What's up guys, my name is Tony, and today I'm going to give you a quick, well, it's going to be a slow and painful guide on installing Linux from scratch. Linux from scratch is a project that teaches you how to compile a FHS compliant Linux system from a very minimal bootstrap set of tools. At the end of this guide, you will have a deeper understanding of how Linux works and will no longer think installing Gentoo is hard. Speaking of Gentoo, for the ISO image today, we're going to be using the Gentoo GUI live CD and drop into a TTY immediately and then SSH into it from another machine. This is because it will already come with the necessary tools to bootstrap a Cross-Toolchain into the LFS system, and besides that, it is relatively minimal. So we'll go ahead and download that here. For the Linux from scratch handbook, I will be using the 12.4 stable LFS chunked HTML here. And one thing to consider is I have personally in the past converted this HTML to an emacs.org file for convenience, but today we're going to be using this HTML view with Dark Reader. So let's start off by booting directly into that Gentoo live CD. And we see this KDE nonsense. We can immediately just drop into a TTY with Control-Alt F1 here. So let's clear all this nonsense here. And let's do a set font -D here, make everything a little bit bigger. And we need to create a password for the root user. So we'll do sudo password root. And we need to turn on SSHD, the SSH daemon. Luckily that's already installed on this ISO, which is the reason why we chose it. We can drop into that root user now by typing su-, and now we can enable the SSH daemon here. RC service SSHD start, and there we go. Do a little IPA here. And oh, I just leaked my IP address. I'm just kidding. So now we look at this IP here, it says ENP1S0 inet. Now we should be able to SSH into this machine from our host machine, and the next time we look at this, we will hopefully be rebooting into our LFS system at the end of the video. So let's go ahead and do that. So I am going to be opening a terminal on my host machine here, and this is going to be for convenience so that we can copy and paste commands from the LFS book directly into our terminal here, so we don't make any typos. So to get into that system, let's type SSH root at 192.168.122.57, and let's type yes to confirm here. Password is what we set before here, and there we go. We're in our live CD. All right, so we can clear this and move on to step 0.001. Lock in because this is going to be a long video. So for the Linux from scratch book, head over to linuxfromscratch.org, click on LFS and click read online. And we're going to go for the stable LFS here. And this will be the guide we're going to follow. So it's not that bad. It's a little bit longer than the Arch Linux installation tutorial, but I think it's not as bad as something like, the Ubuntu. The Ubuntu stuff's pretty hard. You got to click next and do this and that and the other. So this is a little bit easier than Ubuntu, but let's move into it and kind of really dive into it, right? So we are going to jump straight into preparing for the build. Now, the first thing here of importance is 2.2, the host system requirements. These are the packages that are needed on the host system. In this case, the host system is literally the Gentoo ISO CD, and there's a reason we picked that, and you're going to find out shortly here. But if we scroll down, we see there is a script you can run to check the compatibility of all of the required tools. So what we're going to do is we are going to copy this entire block, go back to our terminal here, and just paste that right in. Now we do have that version check.sh script. So we can actually just run that now. So we'll do bash version check.sh. And as you can see, everything passed. So I've tried LFS on various different ISO images, and a lot of this stuff doesn't end up passing. And there's things you have to kind of do to get around that. And that's all right. But for convenience, I do think that the Gentoo GUI live image is the perfect ISO for this because it contains all the necessary requirements to build LFS. So looks like we're good to go. So now that we've confirmed that our dependencies are up to snuff with the LFS requirements, we can immediately start creating partitions for our LFS system. So the LFS tutorial does not provide a literal blueprint on what to do for the partitions. It just provides the guidelines, but I will be able to guide you on what we will do today here. And clear that. This part will be familiar to those of you who have installed Gentoo, Arch, or even Nix using the minimal ISO. So first thing we're going to do is type lsblk to confirm the name of our disk. It is VDA. For you, it may be SDA. So we'll do cfdisk dev VDA. We are going to select GPT for the label because we are on a UEFI system. And for the partitions, let's do a 1 GB boot partition. Let's change the type to EFI system. For the swap, let's make a 4 GB swap. Type is going to be Linux swap. And for the root partition, you can just use the remainder of the space here. 45 GB should be sufficient. And let's make the file systems. For the root partition, we're going to do mkfs.ext4 dev vda3. And for the boot partition, we'll do mkfs.fat-f32 dev vda1. And for the swap, mkswap dev vda2. And there we go. Now it's time to mount those file systems. The LFS guide recommends exporting a variable called LFS to equal mnt LFS, which is going to be very convenient for us. So we can copy that, paste that in, test if it worked by typing echo LFS. There we go. And it also recommends to set the umask to 022. If we run umask on our system, we see it set to 0022, which is effectively the same thing. This will ensure that newly created files and directories are only writable by their owner, but are readable and searchable by anyone. So let's run umask 022 to confirm that. As you guys can see, it's the same thing. We're good, so we can clear that. And we're ready to mount these file systems. So the differences between the commands here and the ones I'm going to run are very minuscule. I'm going to be combining these into one command, and I will not be using these parameters. V is for verbosity, T is to declare the type, which we have already declared. So I'm going to run mount --mkdir to tell mount to make a directory if it doesn't exist. And we're going to mount dev vda3 to LFS. With our boot partition, we need it to be mounted to LFS boot EFI because we're on an EFI system. So I'm going to do mount mkdir dev vda1 LFS boot EFI. And for the swap, we're going to do swap on dev vda2. We can go ahead and confirm this here with lsblk. We see that our boot partition is mounted to mnt lfs boot EFI. Our swap partition is turned on, and our root partition is mounted to mnt lfs. So one last thing here. The book suggests that you should change ownership of the LFS directory here to root and change the permissions of it, which we're going to do by copying and pasting these commands. Chown root LFS. And change mod 755 LFS. And let's confirm that with ls la LFS. We see it's owned by root and the permissions look good. So we are ready to move on to chapter 3. So for packages and patches, we're going to be using a lot of packages here today to build our Linux from scratch system. And the book recommends to make a directory in LFS called sources. So we will go ahead and do that. So before I do anything here, I'm going to run something called screen, which is a very minimal version of tmux that is built into most Linux systems. So I'm going to type screen-s to name this screen LFS. So if I list all the screens, you can see that LFS is the one I'm attached to. If I press Ctrl-A-D, it detaches me to it, just like tmux. So if I want to pause what I'm doing, I can just detach the screen and something that's compiling will not stop compiling. So to get back into that screen, we'll do screen-r LFS, and now we're in a screen. And moving on, let's make that directory now. So we're going to copy this command here. And that's going to be where we will download these sources. And to make it sticky, it means that multiple users have write permissions on the directory, but only the owner of the file can delete the file within the sticky directory. This will help ensure that our host system doesn't do anything nefarious to our LFS system while we're building it. And now it's time to retrieve the wget-list and the MD5 sums. So what I'm going to do is I'm going to right click this, copy link, and I will cd into LFS sources. And clear that, and I'm going to type wget, and I'm going to grab these. This is that wget-list. And I want to get these MD5 sums to verify that we actually got all of the required sources. So we'll do wget the MD5 sum URL. Now if we ls, we see we've got MD5 sums and we've got the wget-list. So we can clear that. Let's take a look at this wget-list here. We'll type less wget-list, And you can see it's just a list of URLs for all the packages we're going to use today. So we've got Glibc, Coreutils, Bzip, OpenSSL, Ninja. We've got several packages in here. And in order to download all of these, we can use this command wget input file and specify that list, and it'll run through that entire list and wget the entire thing. So this is where I recommend having a screen, because if I run this in a screen, I can detach from the screen and reattach and know that it will still continue. So I'm pasting this command here, wget input file with the list, and it's going to put everything into the LFS sources directory. And I'm going to hit enter here. And this can take a very long time. So I will let this rip and I will see you in a minute. All right, it looks like that finished here in about 20 minutes. Not too bad. So let's confirm that we have all the contents of the wget-list by running the md5 sum check. And as we see here, we have this md5 sum-c command. Now, they're doing a push D to LFS sources. We don't need to do that since we're already in the LFS sources directory. So let's run that command and pipe that into less just in case. Looks like everything is good except Attr. So we need to figure out what's going on with Attr here. Maybe the download failed. So this is actually a pretty good example of something that's not going to go perfectly. We need to address that. So let's grab the Attr package. Not going to waste time figuring out what happened there. I just assume the download failed at the time. So if we open up this wget-list, we do see the URL for Attr is right here at the top. So go ahead and copy that. Go back into here and just type wget, paste that, and it looks like it's connected now. So I can watch the footage back and see what happened there. I just assumed that it couldn't connect. But now we can rerun this md5 sum check, and it looks like we got everything now. So that's perfect. So don't forget to run the md5 sum check. I know a lot of people don't run it. It's really important for us to run that so that we can get a good finger on the pulse of all the packages we have and whether or not any of them are corrupted. So as we see here, they're all verified, meaning we have all the necessary packages to move on. And we see the book at this chapter recommends that we change ownership of the LFS sources directory to root. Now we already are root, so we do own that. But just to be safe, it does not hurt to run this command here. Chown root LFS sources. And if we do an LSLA, we see that everything is owned by root. All right. And with that, we are ready to move into chapter 4. So let's jump into it. We do see these two links here, all packages and needed patches. We don't actually need to look at these since these are covered in the wget-list, as well as these. So we can just move on directly to chapter 4. So we want to actually create the LFS file system here, and we need to create some directories like so. And these are your standard Linux directories to be FHS compliant. We have etc, var, user, bin, etc. And etc is going to be that miscellaneous directory. It's usually for system configuration files or what have you. And then we've got var, which is short for variable, obviously. That's stuff that changes, varies, etc. during operations like logs and caches. So for example, a log file will live in var because the log file will change because it's variable. So that's actually a pretty good naming convention. USR is originally for user files, but now it stands for Unix System Resources or Universal System Resources. And that just contains programs with read-only data. Bin is obviously binary, so that's just going to be our standard binaries. Lib will be any shared libraries needed by those binaries. Sbin is going to be the system binaries. We could get into more detail later, but for now, let's jump into creating those. So we'll copy that command there. Let's clear this. And let's run this. It's makedir-pv. So P is a flag that just tells makedir to create all the subdirectories included in the command. And V will give us some verbose output. So there we go. We've got user bin, user lib, user sbin, we've got var, we've got etc. We are starting to look like a Linux file system. Let's run this for loop here. To symlink our binaries to user. And this will be for the lib64 directory in, it's going to do a case check on your uname-m. So if we run uname-m, tells you the architecture. So this command will conditionally run if you're on x86_64 architecture here to create that lib64 directory. So definitely run that because most of you guys are probably on AMD 64. So we can clear that for now. And let's make that tools directory here. We will use this to keep some of the temporary programs we'll be compiling. And we are ready to move on to adding the LFS user. So we want an LFS user here because running things as root could break our system. And if we do it as LFS, we don't risk nefariously affecting the host ISO in any way. So let's add the group and create the user like so. Group add LFS. And user add -s to tell the shell to be bash, -g to tell the group to be LFS, -m to create the home directory. And I actually didn't know about this -k parameter until I read the LFS guide, but it tells you here that it prevents possibly copying files from the skeleton directory, which means that every file will be copied to a dev null as a default input here. And then the name of the user is LFS. And we want a password for LFS so we can log into it. Obviously I have a secure password there. We want to give LFS full access to all the LFS directories. So we're going to run chown-v LFS on all these directories here. There we go. That's the expected output. And then we need to do the same thing for the lib64 directory since we are on the 64 technology. All right, we're ready to switch into our new user. So we're gonna get a warning here. I think on some hosts, the su command does not completely properly suspend. We can actually ignore this because we are on a Gen 2 host ISO and it doesn't behave like that. So let's just type su LFS. And there we go, we're on the LFS user. That's crazy. Let's set the environment up for this user now. So we want to create a bash profile. We're going to cat this bash profile in here. It's going to set up our PS1 prompt, etc. here. And as well, to ensure that no unwanted or potentially hazardous environment variables from the host system leak into our build environment. Do want to set the home to home as well. Now let's grab this bash RC, set it up and explain a little bit of it while we copy paste it here. So the main things here are going to be setting +H, which turns off the hashing feature, which we need to disable in order to force our shell to search for the proper path whenever a program is to be run. The rest of these options are things we either already did, such as umask or exporting the LFS variable. And some of the stuff, lcall, etc., can be explained here and here. So we've got a lot of extra stuff here in this bash RC. And if you're curious about what they do, just check out 4.4. Now, if we scroll down, we do see this important block here. We don't need to do this on Gen 2 because the user's environment is already clean of the etc bash rc. Now we want to update our make flags to reflect our CPUs. Now on this machine, I do have 12 logical cores, so I could hard code this to 12, but it's better to just use nproc to get the true value of your cores. So I'm just gonna copy this here and append the make flags here to be dynamically set by the value of nproc. To show what nproc does here, we see it's going to return 12, just returns the number of logical cores you have. So if we add this to the end of bash rc, and then we source our bash profile, now we can see if we echo make flags, we have -J12 there, and that's going to help us for compiling faster. So yeah, we're ready to move on to the SBUs. So the SBU is a standard build unit. It is an approximation on how long it will take to compile or install a package. And there's no action items in 4.5, but to explain a little bit of what this is going to do, when we compile our Cross-Toolchain, we're going to time Binutils, which is the first tool we're going to compile. And that's going to be set at 1 SBU, so 1 unit. And then we can compare anything else to that by reading their estimation of how many SBUs it should take. So that'll make more sense in a minute when we actually compile Binutils, but for right now we are ready to talk about test suites a little bit. And here it just says that test suites can't run in chapters 5 through 6 because we're cross-compiling. So we're gonna run them later inside of the LFS Chroot environment when we are agnostic to the host machine. But yeah, we're ready to move into chapter 5 here. And that's going to be compiling the Cross-Toolchain. So for the overview of chapter 5, first we need to compile a Cross-Toolchain and then use it to build temporary tools so that we can eventually install the permanent system. We have to separate these stages because cross-compilation prevents any dependencies on the host system, ensuring a clean, self-contained build. So we can go ahead and look at the first page here. This is Binutils. And as I was saying earlier, it's 1 SBU, but let's talk about this a little bit. So each tool is going to be a 3-step process that we're going to repeat a lot. So the first step is going to be to untar the original source tarball, and step 2 will be to follow the instructions in each LFS page. So for this one, it's going to be following these instructions to actually compile and install this. And then step 3 is going to be to move back into the sources directory and clean it up. So we will repeat this process over 100 times today. So I'm going to go slow for the first few times. And after I finish 3 or 4 of them, you will start to see the pattern here. And in my opinion, that's the real benefit of LFS because it teaches you everything about every tool on your system and what it is and what it does. So that being said, let's jump straight into Binutils. And the Binutils package, as we see here, contains a linker, an assembler, and some other tools. And some of these tools you might be familiar with, such as strings, size, strip, etc. And we're going to have to compile this 3 times. So when we compile it the 3rd time, I'll explain a little bit more about what it does. But it is a prerequisite for everything we're going to need to compile here. So let's clear this. And let's see into our sources directory here. And as I said before, there's going to be a pattern here. So the first thing we're going to do with all of these is untar each respective tarball. So this one's going to be Binutils. So I'm going to do tar xvf. I'm going to type bin and press tab, and there it is. There's that Binutils 245 tarball. So I'll cd into that. Now inside of this, we can follow this documentation on what to do here. So we need to make a directory called build and cd into build, and we want to time this entire process here. So it's got a configure prefix and then a make and then a make install. So let's copy this configure preparation and let's run time. And make install. And this will tell us how long 1 SBU is. Beautiful, beautiful compilation here. So that took 26 seconds. We can kind of assume that 1 SBU will be around 26 seconds, roughly half a minute. So if we look at anything in the LFS manual here, for example, if we look at GCC, it says it's 3.8 SBUs. We can use this 26 seconds as a reference. So 3.8, we'll call that 4. So about 4 times 30, about 2 minutes. So we can expect, and we'll test, but we can expect GCC to take about 2 minutes. But anyway, once that's complete, we're going to go back into that sources directory, and we're going to clean up this Binutils because we're going to need it later. So we're going to do rm-rf Binutils 245 to get rid of that directory and move on to the next tool. So GCC here, that's going to be pass 1. It's going to contain the GNU compiler collection, which includes C and C++ compilers. You're probably familiar with this. If you've ever compiled any C code, you've definitely used GCC before. This will be our first pass of GCC here, and this is simply so that we can cross-compile all the necessary tools in Chapter 5. So let's untar that. And then we'll cd into that GCC directory. And there's still some dependencies we need, so let's run these tar commands. I'm gonna move that. I'm gonna rename this GMP here. And right now, I am doing this on 2 different windows here, but when we move into Chapter 5, I'll probably switch over to 1 window because we're going to be copying and pasting a ton. But yeah, we need those extra sub packages and we need to rename them. So we just ran these commands here. And on 64-bit hosts, we need to run this case. So let's run that. And now it's time to make the build directory. cd into that build directory. And prepare for the GCC compilation. And we're going to time this as well here. So let's run time. Paste that. Double-land make install. And we can just run this here to time to see how long GCC is going to take in terms of SBUs. Now, if we want to confirm our theory, it should be around 2 minutes, but let's hit this and let it rip. All right, looks like that finished. Took about 3 minutes, so the SBU calculation is a little bit off, and that's fine. We need to recreate this header file with this command. And there we go, done. GCC Pass 1 is complete. Let's go back into sources, clean that up, and we're ready to move on to the Linux kernel API headers. All right. So these are going to be the headers that provide the kernel interface that glibc is going to use to interact with the Linux kernel. So we're back in sources and we're going to untar this first. Tar, xvf, Linux, cd, Linux 6.16. All right. Now that we're inside of this folder, we can run make mr proper. And as we see here, it says less than 0.1 SBU, which means it's just going to be very fast. Let's make the headers. Let's run this command here. Copy these files over to USR. And that's it, done with headers. Let's move on to glibc here. Go back to sources. RMRF Linux. That's funny. Get rid of that folder. We're gonna untar glibc here. And we're gonna cd into glibc. So this is the main C library here. First thing we need to do is create these symlinks for LSB compliance, which is the Linux standard base. It depends on your architecture. So we can run this case statement to create symlinks for where the dynamic linkers need to point to respectively. Let's copy that, paste that here as we see. It takes into consideration your architecture. And there's a patch that needs to be applied because some of the glibc programs use the non-FHS compliant var-db directory. So I guess if you're a NixOS user, you might be familiar with this non-FHS compliance. Let's run that though, copy paste. And there we go. Patch succeeded. Let's make that directory. For the build, let's cd into the build directory. Make sure that our ld config and sln are installed here. And this is a little bit of an Easter egg here, but because of the amount of lines that I'm showing on this SSH terminal, config params cut off on params. And I've got this little RMS Easter egg, and I'm wondering if maybe he's somehow telling me something, because he wrote glibc, right? So maybe Richard somehow wants to talk to me. Let's configure those. And run make. This might take a little bit of time. All right, not too bad. Need to install this, but set the directory for the destination to be LFS. Need to fix a hard-coded path here with sed. Couple of sanity checks here for the symlinks. And this is the expected output, requesting program with no errors. So that looks like that worked. So we're gonna expect to see this is the output for this grep command. And that's right. And this will be the expected output for that grep command. And that's right. This looks correct. Yep. All right, let's check that. Correct. Look for this found x8486. x8464 here. And that is correct as well. So we've completed glibc here. Let's clean up this dummy log in the a.out file. Go back into sources and get rid of that. And that's it. We've got glibc. We are ready to move on to the last tool in chapter 5, and that's going to be libstdc++, and that's 0.2 SBUs. So let's untar that. Actually, this is going to be using the GCC tarball. So we need to re-untar GCC. So tar xvf GCC 15. Go into that directory. Make a build directory. cd into it. And prepare the libstdc++ for compilation. Run make. And make install here with that destination directory of LFS. And remove that libtool archive file because they are harmful for cross-compilation. Actually, remove all those files here. And that's it. That is the end of chapter 5. So ready to move on to chapter 6, which is the cross-compilation temporary tools. So chapter 6 here, we see the quote from the LFS manual. This chapter shows how to cross-compile basic utilities using the just-built Cross-Toolchain. Those utilities are installed into their final location but cannot be used yet. Basic tasks still will rely on the host tools. Nevertheless, the installed libraries are used when linking. This is my written article to accompany the video here. We've got a lot of packages here. Ncurses, bash, Coreutils, patch, sed, tar, etc. You've probably seen a lot of these. We need to cross-compile these temporary tools here, and a lot of it is going to be copy-paste, etc. So for this situation, I am going to switch over to a more copy-paste friendly setup here, and I recommend you do the same. So now I've got the browser here on the left side, and then the terminal here that I'm SSH to on the right. So let's jump into M4 1420. This is the macro processor package. Let's get out of the GCC folder here. We're going to tar xvf m4 cd m4 and immediately start configuring this. Run make here to compile that. And then we'll make install into that LFS directory. And we're done with that one. Go back into sources here, clean that up, and move on to Ncurses. So the Ncurses is a package that contains libraries for terminal independent handling of character screens. That's what the description says. But if we actually want to figure out more on what it is, we're going to compile it later. It has clear, which is the one that I just ran over and over again. So let's build that here. CD into that Ncurses directory. Make their build. Looking at that here. Let's push D build. We can configure this. I'm going to make this with some C flags. Looks like we're going to install progs here, and then we can get out of that, push a D with pop D. Now we can configure the build for Ncurses. And this one is about 0.4 SBUs, so not too bad. So that's ready to go. We can make it. And we can make install it here. Create that symlink. Looks like we're fixing a header file. And there we go. Ncurses is done. Moving on to bash. Let's untar bash here with tar xvf bash 5.3. CD into that folder. This is really good YouTube content here. We're going to copy that command and paste it into here for the configure. And once we compile maybe a longer package, I might go on a rant, I might not. I got a lot of stuff to say here about the fact that this is a 10K subscriber special video. But let's talk about bash for now. We're installing it here. And we're making a symbolic link from sh to bash. So now we've got bash here. This is the born again shell. I mean, if you don't know what bash is, I feel like I want to explain what bash is, honestly, in good faith, but let's move on. We don't have much time. We've got so many packages to cover, and bash is one of the most popular. Yeah, you know what bash is. Looks like bash is done, so we can get out of that. Clean that up. Move on to the Coreutils. Let's untar that. CD into Coreutils. Let's prepare it for compilation here. It's about 0.3 SBUs. Let's make that. I'm going to explain the Coreutils. I'm going to explain all these in chapter 8 when we actually install them, because this is the third. We're going to install everything 3 times. We need to move some programs to their final expected location here. Looks like that's for the man directory. For the docs. So again, I'm going to explain this later, but let's jump into it now. Let's just kind of see what some of these utils are. Chroot, chown, chmod, cat. Sure you guys are familiar with that. CP, we've run that before. DD, that's to create, for me I use it to create disks, bootable disks. DF, DU, these are information about disk space. Dir, I guess that's an alias of ls. Echo. Install. ln, ls. md5 sum, mkdir. Move, which is rename. NoHup, I've used that before. nproc, that's what we use today to determine the number of logical cores. pwd, path to directory. rm, use that a lot today. Sort, it's a good one. Tail, use that to check out logs. T actually is an interesting one. I use it to bypass the necessity of running things as root after a pipe when putting standard output into a file. Uname gives us the kernel information. All right, we're done with Coreutils for right now. Let's move on to Diffutils. Configure that. We'll make it and install that there. And Diffutils was pretty quick. It's going to be important for later. Ready to move on to file. So tar xvf file 5.64. Let's cd into that directory. Make that build directory. Push D into build and run this configure here. We can make now. And we can pop D. Now we've got a temporary copy of the file command here. Ready to build that. Compile it. And install it. And remove that libtool archive, because again, it's harmful for cross-compilation. All right, moving on to Findutils. Clean that up. Tar xvf find utilities. cd find utilities. Prepare for the compilation. This is going to be exciting stuff here. Let's take a look and see how much stuff we've got left for chapter 6. We're about halfway done with chapter 6. Compile this and install it. Findutils contains find, xargs, and locate, etc. Moving on to Gawk. We can tar Gawk here, cd into it. Looks like we want to ensure that some unneeded files are not installed with this sed command. And we're going to do a .configure here for the pre-compilation. Can run make on that as well to compile it. And we will install it now. I've used awk before to replace certain things in strings, but it could be more powerful than that. It is a GNU utility. Clean that up and move on to grep here. This is one of my favorite utilities, the grep. Let's prepare that for compilation. Compile that. Install it. And that was pretty quick. Let's check the contents. egrep, fgrep, and grep. Let's move on to Gzip. Let's untar that. cd into it. Prepare Gzip for compilation. Install it. And Gzip contains tools to handle zipped files. Zcat is one of the most important ones for me. It's to decompress the file and give you standard output on it. I've used that a lot in the past to compare the... I've also used zdiff as well to compare a diff on some files that have been zipped. Can show you guys more about that later in the future here, later on in this video. Move on to make. This is actually pretty inception moment here. Let's clean up Gzip. And let's untar make. This is going to be funny here. Let's configure this. I think this is hilarious. We're actually going to run make to make. We just compiled make with make. And then we installed it with make. So I think that's humorous for me. We want to patch. Gonna prepare for that. Compile that. Install it. Clean that up. So patch is a tool that is used to apply patches to files, typically using the diff utility. We've already been using that so far to apply small patches to some of these install files. Let's get sed here. And install that. So for sed, I think it literally just has sed here. Let's move on to tar. So we're going to run tar xvf on tar tar. So I thought make was ironic. This is even more ironic. We're tarring tar. That's funny. Let's get into the tar here. Compile it and install it. Move on to Gzip. This is a package that contains compressing and decompressing files. Let's check the contents here. See if any of these are recognizable. Grep, Grep. Says compressing text files with Gzip yields a better compression percentage than traditional Gzip. So we're going to be using that later. Let's untar it. CD into that folder. Prepare for that. Compilation. Compile it with make. Install it with make. And remove that lib tool because it's harmful for cross compilation. All right. Binutils Pass 2. Clean up that. Let's untar Binutils again. So we need to run the sed command to avoid inconsistencies with the host distribution and the LFS build. Make that build directory. CD into it. Let's prepare it for compilation. Should take about 15 seconds. Let's see. Roughly. Okay. Let's install it now. Remove that lib tool. Remove that set of libtool archives here that are considered harmful for cross-compilation. Let's get rid of Binutils because we're going to have to do it again for Pass 3. Same thing with GCC here. GCC Pass 2. Let's untar that. Looks like I forgot to clean that up last time, so let's remove that folder. And untar it again. Go back into it. So this situation might take a little bit of time here. I'm gonna run these commands and I'll show them, but I'm gonna mute my mic here. I want to time this here, so I'm going to run the time command on it. And I will see you guys when that's done. Looks like that took 4 minutes, not too bad. I've seen some people have GCC Pass 2 take about 20 minutes. I do have 12 logical cores on this machine, so that's pretty good. So we need to create this utility symlink because many programs are going to be running CC instead of GCC. So let's do that. And with that out of the way, let's take a peek at the contents here. We've got CC, C++, GCC. This is all standard stuff. But with that out of the way, we are done with Chapter 6. So we're ready to move on to Chapter 7, which is to create more temporary tools and enter the Chroot environment. So with that, let's move on to Chapter 7. All right, so Chapter 7 is about entering the Chroot environment and building some additional tools here. So we're gonna have about 5 or 6 packages where we're gonna do that tar cd compile make install workflow, but before doing that, we need to actually set up the Chroot environment. So in order to handle this situation, we need to become root here. So let's exit out of LFS, and we need to make sure that LFS is still defined in the root environment. And there it is. So now we should be able to handle this and change all of these as well. And we have successfully done so. We can move on to preparing the virtual kernel file systems. So let's create these LFS dev proc sys run directories with this command here. And we're going to be mounting them here. This is similar to on Gentoo, when you mount all of those file systems here. We do want to run this if else block here for dev shm. And there we go, we've got them all mounted. So we can confirm that that looks good here. And we're ready to jump into the Chroot environment. Now, to do that, we can do this Chroot statement here. And there we go. And it's normal for this to say I have no name because we don't have a password set up, or we don't have a password file set up rather in etc password, which we'll get into shortly. But we can confirm that this Chroot environment is set up correctly by echoing some of these. Let's echo the make flags. Perfect. And test suite flags as well. Looks good. And clear that. All right, so before jumping into the compiling of some of these tools, we need to make some directories here. Boot, home, mnt, etc. Let's make those here. And let's get some subdirectories going. etc opt, etc sysconfig. I got the lib firmware. This is some old school tech, but we have a floppy subdirectory in media. All the USR subdirectories. Locale. The local bin. Local share, and then all those subdirectories. Zone info. The man pages. The variable directories for logging and for mail. Color and misc inside the lib. Create this symlink here for run to var run. And run lock to var lock. Install, creating the root directory and the temp directory. Now this is an FHS compliance note, but we are FHS compliant. So again, we're not NixOS, we are Linux from scratch FHS compliant, which is good. So we'll move into creating some more files here. We need to link the mount file here to the etc mtab folder. And then we want a basic hosts file because it looks like Perl's configuration will depend on this, as well as some test suites. And we want that password file so that root can log in. And the group file. So we're going to create this tester user, because he'll be used later in the test suites. We're going to install a home directory for him. And this is going to log us into bash here to get rid of this I have no name, because we do have a name now. We will be creating a var log here with these. We will be creating some var log subdirectories here, because a lot of these programs are going to be recording information in here. Change the group on that. Change the read-write capabilities to those. And we're ready to move on to compiling gettext. So, this part will be familiar here. We're going back to sources. And we do a tar. And we'll go ahead and do tar xvf gettext. CD into that. Get ready for the compilation here. Looks like it's 1.5 SBUs, so it could take about a minute and a half. So I will let that run. All right. So we can run make here to compile this. This is going to be used here to allow programs to be compiled with NLS, native language support. All right. We want to install MSG format, MSG merge, and gettext into our user bin folders. And we're ready to get out of here, clean that up, and move on to Bison. So this is a parser generator. We're going to do tar xvf Bison. CD into Bison here. And let's go ahead and prepare for the compilation. Let's go ahead and compile it. And install it here. It's pretty quick, 0.2 SBUs. Let's move on to Perl here. So clean up that. Untar that and move into Perl. Now for Perl, looks like we're going to run a shell script here to configure it. It's going to be about 0.6 SBUs. So I think the reason we need Perl early here is because autoconf and automake depend on it. But now that we've set up the compilation options, we can make that. And to install it, let's run make install. And there we go, Perl's done. Past 1, we're gonna have to reinstall Perl in chapter 8, but it's okay. Let's move on to Python. So a little bit of a gotcha here with Python. First time I did this. Let's remove Perl here. For Python, when I tried to untar it the first time, I just typed Python and you get this documentation. It's not the correct tarball. You need to do capital P. This is the one we want. So it's capital P and then tab. You'll get to it. Looks like it's containing the entire development environment. But the reason that it is used in chapter 7 here is because we're probably going to need to use Python for some of the test suites, as well as some of the build systems like Meson or even CMake in some cases. But we can configure that here. And it should be about 15 seconds. We can do a make to compile that. And install it here. It's okay, this warning we see could not build with SSL module. As we see in the book here, that's an expected message. It should be ignored here. And there we go, Python's installed. Clean that up. Move on to Texinfo. This is going to be for documentation purposes in chapter 8. So let's untar that. CD into that. Should be pretty quick here. Can make that. and make install. And there we go. Texinfo is done. Let's get the Util-linux. This is some miscellaneous utilities here. Let's take a look at what these are. Block ID, fdisk, kill, lscpu, message here. We got a lot of stuff. Mount. So it's good. It's good stuff. All right, let's make this directory for the hardware clock. And then prepare for compiling. Can do a make and make install. And there we go. We are pretty much good to go here as far as chapter 7. Now we just need to clean up some of this stuff. So first let's remove all of this documentation to prevent it from ending up on the final system. That's going to be 35 megabytes or so. Now we're going to remove any of the .li files. We don't need that tools directory anymore, which is about 1 gigabyte. So there we go. Now this part here, I've done it before in the past on different builds. Created a backup of the current LFS system because it's in a good state. It just takes so long that I'm not going to do it today since I know that this is going to be good. We're going to just install the tools we need and move on. But if you want to create a backup, I think this would be a good time to pause the video and read this section on how to create a backup. It's not very hard. It involves creating a tarball here of all the tools here. And then here's how you would restore it. But we're not going to do that today. We're just going to move on to chapter 8. And that's going to be building out the LFS system. We got a lot of packages to build, so let's jump into it. All right, so we are ready to jump into chapter 8, which is without a doubt the longest part of the tutorial. So basically we need to build all of our tools on our existing LFS system. And we've already built some of these at least once, sometimes twice. In some cases, for example, GCC, we're on Binutils, Glibc, we've already built those twice. So we're gonna build them a third time here. And I'll take a look at this just to show you what we're talking about. We're looking at 12 SBUs for Glibc. That could take a while. So what we're going to do is do our due diligence here. We're going to go back here to chapter 8. And when I install all of these tools, I'm going to explain what they are because I kind of have been skipping over what they do. And this part is actually the most important part. So if you're only going to watch any of this, well, I guess it's too late for me to say this. But yeah, if you're only going to watch any of this video, check out this part and kind of just vibe out with me while I install these tools here. So let's jump into the introduction here. This part is basically what I just said. Package management is an optional thing here. It's kind of a request that people always make about the LFS book is to describe some way to package manage. But it doesn't make sense. It's not appropriate for LFS to have a package manager because you're building everything from scratch. So, yeah, we're not going to do any package management today. It's just not appropriate. So let's just jump straight into the packages here. And we've got the first one. It is the man pages. All right, so we're going to get the man pages here. Let's, first of all, we're going to do the same process here. We tar xvf man pages, and we'll cd into man pages. Now, while we're inside of this, we're going to follow these instructions. This is just a 2-part install here. So we're going to remove this crypt. I guess they want to remove this crypt man page for hashing purposes. It's out of date. So the man pages are just for documentation purposes. If you don't know what a command does, you can run man on that command and then find information about that command in the man page. So that's what that is. Let's move on to Iana-Etc. So tar xvf Iana-Etc, cd Iana-Etc, and now we can just copy the services protocols into one place here. And so this is going to provide etc protocols, and these files are mapping the service names to the port numbers, which are needed by certain network applications to know which ports to use. This is kind of low-level network stuff here, but we need these, so get that out of there now. Remove Iana-Etc, move on to glibc. So this part could take 12 SBUs. tar xvf glibc 242.tar.xz. Move back into glibc here, and it's been a while here. We got to do this patch to deal with non-FHS compliance. Fix an issue that might break valgrind. Make the build directory. CD into it. We're going to ensure that LD config and SLN utilities are going to be installed into user bin. That's right. All right, let's prepare this. Okay. So we're ready to make this. Now this, it could take a while. 12 SBUs could be 20 minutes. Let's see. But let's run this. So I've explained glibc twice, but let's go over it a third time. It is the GNU, which is GNU's not Unix, C library, the core library that provides system call wrappers, standard C functions such as malloc and printf, etc. And basically everything that programs need to run. So it's kind of the most important part about, in my opinion, about really anything. Really, I was going to say like Linux or GNU utilities, but really anything. Oh, that was fast. All right, so now we got to make check here. So we're going to have to run some tests here. And I've had problems with this in the past, so it's really important to run these tests. We got to read some of these issues. Now, we're not going to be able to read the tests, so we're going to have to use the test file. But let's run these right now. Make check. All right, so make check has completed here. And we do see we've got 2 failures, 14 expected failures. And I did run into this issue before where I had this as one of the failures. And I did check the other one was also a known failure here. It was this misc tst pred, I think because the Linux kernel that I'm on for my host is 6.16. That's the Gen 2 kernel. So we are good to move on here. Let's run this touch command here to prevent the warning. And we need to fix the makefile. This doesn't apply to us because we're not on a older version of LFS. This is a fresh LFS build. Looks like they really want to warn us here. Looks like we're good to install here. Fix this hard-coded path for the LDD. Now the locales, I could just grab my locale, but let's grab all these because it'll help for testing purposes. So, zoom out a little bit more here. get the Chinese. Looks like that one's gonna take a while. The Hong Kong, the Taiwan, and we're ready to alternatively could have just ran this the whole time. I just installed every one of them for no reason. I should have just ran this. Well, you know. And we need to create this file here because the glibc defaults don't work well in a networked environment. We need to add the time zone data here. Create the zone info variable. Make the directories for POSIX. Run this for loop. Copy those files over to user share. And we can set it to New York, I guess, for now. That's fine. Now we need to run this script to test it. I'm in America here. And you guys know I'm in the United States, so we'll do 49. And let's do 21. Yes, that's correct. So the TZ select works, meaning we can move on to the next step here. So this, replace this here. For me, I'm going to do America, Los Angeles. This is that command that we always run on Arch Linux, ln-sf user share zone info, and then I always say, for me, in my situation, I'm in Los Angeles, but we can run that. Looks like we've got to configure the dynamic loader here. If desired, the dynamic loader can also be, yes, exactly. This is desired. It can also include the contents of files found there. And then we need to make that directory as well. So we've got that created, and that's it. glibc is done. We got zdump, zik, sln, pldd, gencat, getconf. We got everything. So let's move on to zlib. All right. For Zlib, what it is it's a compression library that's used by tons of programs for Gzip compression. Nearly everything that deals with compressed data needs this, so we're going to grab this. I did have an issue with it on my build before, so let me see what that was. Let's try it here and see kind of what happens. Well, we didn't go here. So for Zlib, let's tar xvf zlib. Move into Zlib here and run this configure command. Let's do a make check. Looks like the test is good. Now we do a make install. And that looks good, so we can remove that useless static library and then back out here. And we're ready to move on to Bzip. Bzip is going to be another compression library for .bz2 files. That's used by many package managers for archiving tools. It has slightly better compression than Gzip. Let's go ahead and grab the patch here. But first, let's untar it. So if I press tab, it looks like the reason that failed is to untar is because there's a patch file. So let's grab the actual tarball, move into that, run that patch, create the symbolic link that's relative, Ensure that the man pages are set correctly. Okay, we can make now. Yes, we do want to use a prefix for where we want to install that. Install the Bzip2 binary to the user bin directory. And there we go. We've got Bzip2 in symbolic links for bunzip and bzcat. Let's remove this static library that we don't need. So bzdiff I've used before to compare two bzipped files without unzipping them. So yeah, bzip is just another compression algorithm. Move on to xz. Let's configure this. Another compression library for xz files that has better compression ratios. The kernel is reliant on this. So we'll do make. Oh, that's a big wall of text. Make check for the tests. Pass. We're getting a lot of passes. No fails. Perfect. Make install. And there's lzdiff is kind of what I've run as well. And xzdiff. So it's good to go. Let's get out of here. Let's move on to lz. Another compression library here. So tar lz4. I don't know why it wants me to run the... Oh shit, I don't know why it wants me to run the check file with one J flag, but fuck it, let's do it. I've got to mute that. So it makes me run the test with one J flag. I assume that the tests are reliant on only being singular and not parallel. This is another compression library. Like I said, it is... I mean, the kernel's reliant on it as well. It's optimized for speed, so we're going to need that to compress files that are bigger than 500 megabytes per second that we need per core. Okay, that's why we needed to test it with one J flag. Okay, so this LZ4 can be moved on from now. Let's get out of here. Let's grab Zstd. Now, Zstd is a modern compression library that balances speed and compression ratios. It seemingly is an increasingly popular package distribution. It seemingly is increasing in popularity for package distribution and file systems. Let's run the tests. Let's make the file here. Okay, we can install it. All the tests have completed successfully. Let's remove that extra library. I think we're done with compression. So move on to file. So file. Going to compile the file, run the tests. Looks good. We'll send you to check that I ran everything. Yep. File determines the file type by examining their content. Now, if you run file on a binary or something, it can tell you what file it is. You're gonna need that for, I mean, that's essential for scripts. A lot of scripts run file on things to see what kind of file it is. And then they have conditional logic depending on what it is. So let's move over to Readline. We need to run these sed commands. And we need to prepare for compilation. It looks like it's linking against lib Ncurses library. That's why we needed to run with that flag there. Ready to install it. Let's get the documentation. So this library provides command line editing and history for interactive programs. So it allows you to press tab, complete, use arrow keys in the bash shell, etc. So this is really important. Let's get rid of that. Move on to M4. So our second pass, I think, of M4. This is required by Autoconf, I believe, to generate configure scripts. It is the macro processor. Run the tests. All right, we can get out of M4 here. Move on to BC. All right. Set some defaults. All tests have passed. Let's install that. So BC is a precision calculator that we use in a lot of scripts because the Linux kernel build system needs it for calculations that bash can't handle. All right, we got that. Let's get out of here. Move on to Flex. Passes every test here. You can install it now. This is important here. A few programs don't know about Flex yet and need to know about it, so we need to create these symbolic links. Now Flex will be that fast lexical analyzer generator, so that's going to be used by many programs to parse config files and programming languages, which we are going to need for several other packages. So now that we've got that, let's remove it. Move on to TCL. Need the SRC. Going crazy here. So source dir is that. CD into that Unix directory. Need to build this package here. And then run these sed commands that are going to remove references to the build directory from the configuration files and replace them with the install directory. It's not mandatory for the remainder of LFS, but may be needed if a package built later uses TCL. So what is TCL? Let's talk about TCL. TCL is a tool command language scripting language, primarily needed here as a dependency for expect, which is needed for running test suites. Pronounced tickle. Okay, interesting. Let's run those sed commands. And unset that source directory variable. All right, let's look those tests pass so we can run make install. And let's change the privileges of this file here, as well as that one. Let's get the private headers. Create that symbolic link. We need to rename that page that will conflict with the Perlman page. And then optionally, let's do this. Let's create the documentation using these commands here. And it looks like we're done with TCL. Let's move on to expect. We're going to use Python to build this here, looks like. We need to test this Python script here to make sure that it works. Looks like we're good. Let's apply this patch. And let's configure this. So expect is an automated interactive okay, let's make this. Run the test. Expect automates interactive applications. We will need this to run automated tests on programs that normally require user input like passwords. So this will be good for the remainder here. It looks like password right there, just like I said. It's going to be useful for testing stuff here, so let's install it. Let's create that symbolic link. Communicates with other interactive programs according to the script. That's right. That's right. Let's clear this. Let's get DejaGNU. And build that and cd into the build directory here. I think it's one at a time here. This is that testing framework that's built on expect and TCL. It's going to be used by GCC and Binutils to run their extensive test suites later. Move on to Pkgconf. This will be for retrieving information about installed libraries. This is going to replace Pkgconf and help the system find library locations. Create those symlinks for compatibilities here. Get rid of that. Move on to Binutils. Pass 3, if you will. Let's make that. We need to run these tests here. So let's run those here. And then we can inspect the tests by looking at the log after they're done. So let that run. So we need to take a look at some of these failures here. Looks like we're good here. We can move on to installing it. And let's remove the useless static library. So Binutils explained a couple times here, but one more explanation here. It does include a assembler and a linker, and these tools are going to be used for manipulating object files, which are critical for compiling everything. So we talked about strip, size, strings, but also LD. It's that linker that we were using to compile things, right? So, and here's the assembler. So we got Binutils, and that's the last time we need Binutils. Let's move on to GMP. Ignore that because we're on 64-bit. Looks like the test suite is mission critical. Make that and then make the HTML. And this is the kind of check that I like. It outputs it into the log, and then we can check that log later with grep. So let's run that check. Looks good to me though, just eyeball checking it, everything's passing. We can run this awk command here. Yeah, 199 is what we expect to see. That's the number of, that is the number of tests that we want to see pass there, so we can install it. And install the HTML. So GMP is the GNU multiple precision library. It's an arithmetic library required for GCC for optimizations and by many other programs that will need to do math with super large numbers. So libgmp is proficient. So libgmp is for precision math functions, and then libgmpxx is C++ precision math functions. So we need to cover that. And get that out of there and move on to MPFR. The fuck was it? Okay. Let's cd into MPFR. This is also for some floating point math here. And make this, make the HTML here. And we do have another warning here. It says it's mission critical to run the chest. So let's run them. Looks good, so let's install it. Install the HTML. This is MPFR is multiple. So this is going to be multiple precision floating point reliable library, MPFR. It's also required by GCC for floating point operations during the compilation optimizations. Let's move on to MPC. Oh, I'm getting ahead of myself. Let's run those tests. Looks good, no errors. Can install that and then install the HTML. So MPC is multiple precision complex library, yet another GCC requirement for complex number arithmetic calculations during the compilation. Let's move on to Attr. Dude, I keep doing this. Okay. Pass the tests. This is going to be the library and utilities for managing extended file attributes. This is needed by other packages and for full file system support, as we see here, ext4, ext2, etc. But that's a small package, so we can move on to ACL. Same thing here, configure, compile, test. Oh, we got a fail. cp.test. But that's okay, because right here it says one test named cp.test is known to fail because Coreutils is not built with the ACL support yet, so that's okay. Just kind of woke me up here because I wasn't really paying attention, but I'm glad that that's covered right here. So ACL is going to be the access control list utilities for fine-grained file permissions beyond traditional Unix permissions. This is required by some programs and useful for complex permission setups. I've never personally used these, but they're probably used in some scripts that I have used under the hood. Looks like we can move on to the libcap here. We're going to prevent some static libraries from being installed. Going to compile those, run the tests. And looks like the tests passed and we can install them. So libcap, we've got cap.sh, getcap, etc. This is going to be a library for getting and setting POSIX capabilities that allows programs to have specific privileges without running them as root. So you can examine file capabilities, etc. That's going to be important for scripts. A lot of these are important for scripts. Move on to libxcrypt. Compile, test, looks like we're passing everything. Good summary there. No fails, and install it. And regarding this note here, this is about obsolete API functions. We don't need to worry about that right now. It's not going to be necessary for us. Well, let's back up and explain a little bit about what this package is actually. This is the extended crypt library package. It's going to be used for password hashing. This is going to provide the password encryption functions used by login, passwd, and authentication systems. So this is a dependency for passwd, I believe, and login. All right, let's get out of that. Remove that. Let's get shadow here. Move into shadow, and if you've installed Linux PAM, you should follow the BLFS instructions instead of this. We didn't do that, so we can stick here. I would not like to enforce the use of strong passwords. So let's go straight into disabling the installation of the groups program here with these sed commands and the find commands. You can ignore the warning about BLFS. Let me create that password file. Compile that. What are we looking at? 1 SBU, 0.1 other. Sorry, prepare for compile and then compile here. Now we can install it. All right. So we need to enable the passwords here with Pkgconf, and then also the group passwords here. We got to make this etc default directory, and then we need to add 999 as the default GID for the group, for the user. And yeah, let's disable mail. So we need to set a password for the root user here. Needs to be 5 characters, so my normal password won't work. But we got one that's just slightly longer and not as bad. Just make sure you remember this password because you won't be able to log into your LFS system if you don't. So this has group add, which is something that you probably have all used. Group del, login, logout daemon, password, su, user add, user mod. This is a very important library. I'm not sure why it's called shadow though. I guess it's for passwords. User and password management utilities. Essential for creating users and managing authentication. Yeah, we know that. So let's move out of there. Let's move on to GCC. All right, 46 SBUs. This is the part where I'm going to show this. We may or may not vibe out. We'll see what happens. We'll see what happens. I'm not going to commit to anything. Let's untar it. We got to remove that directory. I guess I forgot to clean that up last time. Get ready for building this here. So this could take a while. Yeah. Looks like that's done compiling, but we need to run some more commands here to give it more stack space and remove several known test failures here. So we're going to change into the tester user to run these tests. I'm gonna time this. No, I'm just gonna run it actually. It's gonna take a long time, so I will let this rip and I'll catch you guys on the other side. All right, that took about 30 minutes. We need to audit those logs now. So we can audit these results with the expected results here. Let's open this up here. Let's go to the logs. Let's click on GCC and let's look at the summary. So we have 2,800. So it looks like we have 2,282 fails here. That's what they had. We didn't actually get these failures. That's okay. For GCC, we had 1,476. And then we had those 4 unexpected. That's normal. Looks like that's what they had. Unix looks good. Libcap looks exactly the same. 4431, 109. So it looks like our fails were expected. And I have seen this part take about 5 to 6 hours before, contingent upon the number of logical processors, logical cores, but for me it only took about half an hour, so that's pretty good. With those J flags, I'm actually pretty excited about that. It's time to install GCC. And let's Chroot. Let's change ownership everything here. From tester back to root. Create this FHS compliant symlink. And add some compatibility. Add some compatibilities here. Do a sanity check. That looks good. That looks good. Here, let's go out a little bit. And we're gonna grep this, and we're expecting to see this, which looks correct. Yep. One more time here. Right, and that's good. That's correct. Okay, now we can remove that log. Let's make the directory here to replace that misplaced file. And there we go. GCC is done. So GCC is the GNU compiler collection, which is the actual C and C++ compiler. This is what turns the source code into the executables. We've been using it already twice. We've compiled it twice. This is their 3rd time. And we can move on to Ncurses. Clean that up. All right, Ncurses, let's go. Configure that. Compile it. Install it. Remove this SO file here. Set this header file. and then run this copy command here. Let's run this for loop. And let's get the documentation. So the Ncurses, I think I talked about before, it has clear. I've been running clear a lot. It is for text-based user interfaces in the terminal, used by a lot of dialogues and menus and stuff. So let's move on to sed. I'm going to compile that. Compile the HTML documentation. Let's run the tests. Should be pretty quick here. That's right. Okay. Install it. Install the documentation. So sed filters and transforms text files in a single pass. It's used by many scripts to modify files programmatically. Move on to psmisc rather. This contains kill all and some other things that will display process information. Move on to gettext. Let's run the test. So again, Gettext is the tools for the internationalization I-18N and translation of program messages. This is going to allow the programs to display different messages in different languages. We have MSGen for the English translation catalog, etc. This is going to be needed. But yeah, move on to Bison. Whoops. So Bison is a parser generator that creates parsers from grammar descriptions. This is required by many programs to parse configuration files in programming languages. So we need that. So let's run make, compile it. Let's run the tests. Looks like the tests were successful here. We can move on to installing it. That was easy. Let's get grep. Grep, I believe, is an acronym for regular expression print, but I forget what the G is. Let me consult Google here. Global regular expression print. That's right. All right, so Grep is obviously something that you guys have all used, maybe. I mean, you've seen me use it today. Let's remove the warning about the potential package failures. Let's prepare for the compilation of grep. Compile it and run the tests. Expected fail on glibc infinite loop. No unexpected fails. Okay. Let's do make install, and then we're good to move on to bash. I'll keep doing that. The born again shell. Bash is the shell we're going to be using to execute the scripts and commands. Prepare for some tests. All right. We're gonna log into the newly compiled bash here. So let's move on to libtool. Libtool is a generic library support script that hides the complexity of using shared libraries behind a consistent interface. So this will be used for many build systems. Let's run the tests. Looks good here. We can install it. Remove that static library and then done. Move on to GDBM. So GDBM is the GNU Database Manager library. This is going to provide simple key value database functionality used by various programs for configuration tools. Let's compile it and run the tests. Looks good. Can install it and then move on to gperf. Gperf is that perfect hash function generator. So let's compile it and run the tests. While that's running, this is used by some programs to create efficient lookup tables at compile time. So this is going to be good for, this is needed for hash functions. Looks good. Let's go to expat. Stream-oriented C library used for parsing XML files. That's good. Do the tests here. A lot of programs are needed a lot of programs need this to read or write XML. So we're gonna run these install commands here and install the documentation. So yeah, expat is required by a lot of different programs that need to parse XML. So let's get rid of that and move on to Iana-Utils. These are network utilities. It contains ping, ifconfig, hostname, etc., traceroute. These are really important for networking and debugging certain networking issues. Let's run those tests. Install that, and we can move this to the correct location here. Should be good to go now. Let's move on to less. I've been wanting to use less this whole time, but I don't have it installed. Now we can finally install it. Literally one of the most, I think this is the quickest text, I don't know, it's not a text editor, but text viewer, I would say. I've tested less. Whenever I use Vim or Emacs to test like how slow something is to open, I can always compare it to less on the same file. And less opens files really easily. Look how fast that is, right? But yeah, we've got less finally, so I can start piping things into less. What's less echo? Never seen that. Okay, cool. So I don't even know what more is, but I guess less is better than more. Oh. Done with less, let's move on to Perl. So for Perl, let's export this build Zlib to false, and then this Bzip to 0. And let's run this script to have full control of how Perl is set up. Now, Perl is a powerful scripting language that's required by many build systems. It's going to be required for test suites, and yeah, I think this is our second pass on Perl, but I don't know, it's been a long time. It's been a long day, so I don't remember. Let's make it here. All right, let's run these tests. Could take about a minute or so, depending on the SBU value and how accurate it is. I mean, 48 SBUs was for GCC, so that should be around 24 minutes. That's about right. That's how long it took for GCC. All right, the tests are good to go here. Pass, perfect. Install it. And then once it's installed, we gotta unset those variables. Ready to move on to XML parser. You gotta use Perl for that. That's why we needed Perl. Run the test, pass, okay. install that XML parser. So this is an XML parser. I believe it's based off expat, which we've already installed. But again, this is going to be required for other tools. Let's move on to this. This is the init international tool here. Let's grab this. Clean up this warning with sed. Configure that. Make check for the test. Looks good. Install it. Documentation. And so international tool, this is actually the internationalization tool for extracting translatable strings from source files. This is going to be used by many projects, build systems. So let's move on to AutoConf. So AutoConf is a package that contains programs for producing shell scripts that can automatically configure source code. Let's run those tests. So this generates configure scripts from template files. It's part of the GNU build system, and it is used by most open source projects to configure builds for different systems. All right, so we've installed AutoConf. Time to move on to AutoMake. Now this is what generates make files from templates. And this works with AutoConf to create portable build systems. So let's make that, and we're going to use a jproc here. I think we could just run make check, but let's specify our jflags with this command. What I find interesting about Linux from scratch is that I think it's not, every package is not simply make check, and make install. Some of them have these jflags that they need you to specify. This one says 4 parallel jobs speeds up the test, even on systems with less logical cores due to internet. Like, this is for people that don't have 12 cores, right? I mean, I'm on 12 cores, so I don't need to use this. But whatever. Any unexpected fails, that's good. No actual fails. Let's install that and get out. So again, I am ready to move on to OpenSSL here. So it's tar xvf open. Let's get ready for this. This is 2 SBUs. This might take a little bit of time here. But this is a cryptographic library and toolkit that's providing the SSL and TSL protocols. I'm sorry, SSL and TLS protocols that are essential for securing network connections such as wget, curl, and countless other programs. These are going to rely on the SSL certifications. It's kind of obvious if you know anything about like how websites work and stuff. Usually there's an SSL certificate right up here. Yeah, exactly. It's usually verified by Let's Encrypt, but all right, let's make that. And we're going to specify nproc to make the tests. Okay. It says here 1 test, 30 test FLG is known to fail if the host kernel doesn't have config crypto. We'll see if that fails. Looks like we didn't even get that fail. So let's make this and install it. We can close that. Let's move this file here to be consistent with other packages and then create some more documentation. So we're good to go for libelf and elf-utils. We are about halfway done with all this stuff. We've got GCC out of the way, and that's the big one to worry about. So let's move into libelf here. So we need to tar xvf elf-utils. Go into that here, and then let's get ready to compile that. Now, libelf is a library for reading executable and linkable format files. This is going to be required for working with those files and debugging. So let's run make. And that looks like it's going to be not too bad here. So make check. We're going to see dwarf source lang check fail, but I don't think the backtrace one will fail. Let's see. Yeah, that's right. The dwarf source lang check failing is known, so we're good on that. Let's run that install command. Let's get that going, and let's get rid of that useless A file and move on to libffi. The libffi, rather. This one might take 2 SBUs, but let's configure it. This one is a foreign function interface library. Let's make this and run the test. So all code that's written in one language can call code to another. This is required by Python. You often hear people say like Rust has a library called randr, and they maybe think that that is a bind to xrandr because they maybe think that that's an FFI to xrandr, but it's actually not. Randr is an extension of X11RB, which is a native Rust library that has no xturn cbinds, but Rust does have a library called X11, which is a FFI. So a little bit of confusion there. Shout out to xsoder if you've kind of got to this far in the video and you saw that. This is an inside joke between me and him, but yeah, let's keep running this and see how it goes. Looks good here. We can run make install now. And libffi is done. So let's get out of there. Move on to Python. So with Python, we got to do something special here. We have to tar it as a capital P. Because it's what's named, that's what it's named here. It takes about 2 SBUs. Let's configure that. Let's run make. Okay, make is good here. Let's do the tests. I believe there is a known failure here. Test SSL is known to fail in the Chroot environment. So Python is a high-level programming language, especially popular these days. It's used for Meson. And yeah, it's used for a lot of configuration tools. Obviously, Python's ubiquitous, so you kind of know what it is, but we're going to be using it from here on out for the build process. Looks like we're actually good here. It looks like the fail actually was reran and then succeeded. So let's go ahead and install this here. And then we need to put this into our pip.conf. We can ignore this root warning. Let's get the documentation. And that's it. Python's done. So we should have access to Python. Yeah, there it is. So now we've got Python on our system. Let's get out of here. Clean that up. And move on to flit core. Oh. All right, so FLIT is a minimal Python backend here. It's used to build Python packages. Let's jump right into it here. We're going to build it with pip. That's why we needed Python before. And we'll pip through install it. And that's it, done. Packaging is another Python library for parsing package versions and requirements. It's a core dependency for Python's packaging ecosystem, so let's pip that. And then pip install it. Done. Wheel. Wheel is another Python library here. It's going to be for the wheel binary package format. So let's pip through that. And let's install that. Setup tools is another Python library. And this one is for installing and upgrading packages for Python. And there we go, done. Ninja. A small and fast system focused on speed. That's what this says here, but it's used by Meson, and other modern projects. It's actually an alternative to Make. It's inferior to Just, but we'll get into that in a different video. Let's build it. I'm gonna do jobs 4, but I think this is optional. Just do 10 here. I'm gonna build this with Python actually, so that's why we need all those packages before. And there we go, done. So Meson is this open source build system that we're going to use. It's increasingly popular and it's required by systemd and udev and what have you. So let's get into it. We're going to probably need it for udev, I assume. Let's compile it with this command here, and then let's install it with Python. And we're going to install these as well. Looks like it's good to go. Let's grab kmod. Kmod is a tool for managing Linux kernel modules. It has modprobe, insmod, rmmod, etc. So this is something that is necessary to handle the kernel modules. Let's make dir here. Probably familiar with a lot of these tools if you've used Arch Linux or NVIDIA. I think I failed a test. I didn't see that though. Actually, no, it looks good. Let's compile this. And then let's install it. And now we should have access to mod info and mod probe, etc. Let's get out of there. Coreutils. Okay, we talked about this once. I think we passed it once. Sorry, that's .tarxz. Let's patch this for that security issue. Patch that. Prepare this for compilation. Now, Coreutils contains ls, cp, mv, rm, cat, etc. These are literally like the fundamental GNU utils that are needed to live on top of the kernel and really call it GNU/Linux, really, essentially. And there we go. We've got autoconf and automake, which we've used earlier for this moment. Let's run the test suite here. Looks like they passed. So we can delete that dummy group and install. Need to move some programs here to maintain FHS compliance, and that is going to be, again, sorry about the NixOS users that aren't cool with it, but yeah, now we've got ls, cp, all this stuff, cat, install, pretty much everything we need. Yes? What's yes? Oh yeah, yes is something that we'll just hit Y forever. You can pipe that into programs that need Y to be passed in as parameters. All right, let's move on to Diffutils. Talked about Diffutils earlier in chapter 7, or rather chapter 6. It's going to be stuff like diff, cmp, etc. for seeing what's different in different files. A lot of scripts will run on them. Although there's a better tool, in my opinion, called Delta, but that's more for visual purposes. Let's get out of... Fuck. I can always do that. Let's get out of here. Let's get Gawk. Again, we already got this before, but let's do it for pass 3 now. Remove the extras, though. Configure that for the USR directory. Universal shared repo. Make that. Get ready to test it. Let's run these tests as the tester. All right, all tests passed. Remove Gawk and then install it. So now we have Gawk, our new build of it. Sim like that, and then get the documentation. So we have awk. We've already used awk a few times in this process to sort of update certain files and stuff. Okay. Findutils. We're going to speed run the rest of this, guys. Findutils. We're almost done. This is utilities to locate or find files such as find, locate, and xargs. This is indispensable for searching the file system and processing lists of files here. run the tests. Looks like those tests passed, so we can run make install, and we've got those find utilities, so let's move on to Groff. So for Groff, we need to change this command. Okay, hold on. Let's zoom in a little bit. This is actually important. So for Groff, we need to run this command, but we need to change this page to letter, since we're in United States. If you're not in the United States, just do A4. So Groff is going to be a GNU trough text formatting system, which will be used to process and format man pages for display. So you can actually read those man pages. Let's run some tests. 2 expected failures, no unexpected failures. Let's install it. And there we go, Groff is done. Perfect. Okay, we got a little gotcha here. You need to pay attention to this part here if you're on UEFI like I am. So hang on a second. All right, so for grub, what we need to do is we need to make a folder called BLFS here because we're no longer in LFS. Let's cd into that. And we need to, are we in a screen? I don't remember if we're in a screen. Here, let's see. Here we are, okay. So I'm in a screen, so I can do Control-A-D. I remember setting up a screen like 15 hours ago. If you're not in a screen, just go to your machine, wherever you're SSH'd into, and run these commands. We need to cd into mnt lfs sources blfs, and we need to grab some tarballs here. So let's open up this blfs page, and let's do it in a new tab, because we don't want to lose where we are. So for blfs, we need grub for EFI, because we are on EFI technology. So we need EFI boot manager, EFI var, and popped 19. So let's start with EFI var. So we're going to copy the link here and do wget. Now we got that. Let's grab all of the tools we need first, and then we'll go back into the Chroot user. So pop 19, we got to grab that. Let's do wget on that. Okay, keep that open, and then keep this open. And then we also need this version of grub. Well, this is the same version. So we're gonna be okay, I think. We don't need free type. I did use free type here, but we don't need it. So let's just stick with EFI boot manager. So screen-r lfs. We've got these 2 tarballs. Let's start with EFI var. So tar xvf EFI var. Inside of EFI var, we need to copy enable docs equals 0. Install that. And this is BLFS, so you have to copy the whole thing because they're using double ands. And there we go. And then for pop 19, let's configure this and make. We don't have Doxygen, we don't need to worry about that. Make install. And then we don't need the documentation here. So we're good on that. So close out of that, close out of that. And we forgot to get that. Yeah, we forgot to get the... Okay, let's remove popped. And we need to grab this, but we don't have wget, so we need to control AD and do a wget on EFI boot manager. Okay, now we can do a screen -r lfs. Should be able to tar that. Okay, now we can install this like so. And then make install. All right, that should be it. Perfect. So we can close that. I think we should grab the free type package because I did it before, and I think it requires a couple other packages here. So let's do that one more, just to be safe here. Let's wget this. Let's make sure, let's do an eyeball check on this. F3B44, yeah, that looks good. Let's go back into LFS here. And then we have to install this like so. We didn't do documentation, we can skip this part. We can copy the whole thing here because it's BLFS. Let's install that, and we don't need to do this because we don't have the documentation. Okay, so free type's done. And now we can finally move on to grub. So for grub, we have, it uses the same tarball as the grub we already have. Let's do an MD5 sum. 60C56, yeah. So we already have that. So we can just tar xvf grub. Now inside of grub, we did get free type, so let's grab these commands here. This G unzip failed here because we don't have that unifont file above us. I think we do though. Yeah. So go back into root. Make sure we have that unifont file here. And that will be done with this wget command here. And this is the URL for that. So that's how you get that. So go back into LFS. We're not going to worry about the flags here. We don't have anything set. Let's add this. And then let's build a grub like so. And here it says if you've skipped the LFS grub package, which we have, we need to run these commands. And this one says if you've not skipped it, only install the components not installed from the LF. We don't need to do that. And we have installed font data, so let's grab these. And there we go, grub is done. So we need to keep this open for later. Let's open that for later, for the kernel. But for now, we're back to this. We can skip grub since we just did it through EFI and move on to Gzip. Let's configure that. Compile. Let's run the tests. All right. Move on to IP route. I already explained Gzip. We're gonna remove this from the makefile with sed, and then remove that man page here. We can compile it now. So this is gonna be installed into our user sbin directory, and here's the docs. So IP route is going to contain IP, bridge, ifstat, nstat, etc. These are some advanced network configuration tools that are sort of a modern replacement for older tools such as ifconfig. So now we should have access to IPA, which is going to help us later. We can clear that though and move on to KBD rather. All right, let's apply this patch to KBD here for backspaces and what have you, and remove the redundant resize cons. Let's get ready for the compilation here. Now KBD is for console and keyboard utilities. Obviously KBD keyboard. Let's go for a make install here. Let's get those documentation. So we're not Belarusian. Actually, Arium might have an issue with this. For some languages such as Belarusian, the KBD package doesn't provide a useful key map for the stock by key map. You're gonna have to download that separately if you're, I guess, Belarusian. I don't know. Put it in the comments if you've gotten this far and you're still paying attention to what I'm saying. Cool. Lib pipeline time. Library for manipulating pipeline and subprocesses in a flexible, convenient. I wonder what that means. I'm pretty sure lib pipeline is used by ManDB to handle complex pipelines efficiently. I think that's what they're talking about. Let's compile this and then install it. Let's see what contents are in there. Safely construct, yeah, exactly. That's needed for man. Okay, we're gonna make again. Let's do it, tar it. I always think this is interesting when we run make here on make. Let's test this. This might take a little bit of time, probably like 20 seconds. Looks like it passed those tests, and then we make install. Okay, perfect. Did we miss anything? No. All right. Patch. Lol. This is applying those diffs. We've used it a couple times already before. Tar. I'm going to tar it again. Run some tests here. We got one fail here. We need to know what that is here. Okay, so it says here that the binary store restore is known to fail if it is run because LFS lacks SE Linux, but will be skipped if the host kernel does not support extended attributes. So it looks like that's the test that failed. Binary store restore. So we're actually okay. That scared me a little bit, to be honest with you, but we're good. Glad we have a less finally. Cool. Let's get out of there. Move on to Texinfo, pass 2. Let's get rid of that code pattern here that will cause the Perl warning. Let's do a make and a make check. And then we'll take a look at the test and then we'll run make install here. So Texinfo, again, we talked about this before, but it's a documentation system that will produce both online help and printed manuals using LaTeX, I believe. But okay, that passed, so we'll run make install. And then optionally, let's grab this. See, this should be on some type shit, you feel me? Okay. I mean, we can do this just to be safe. I don't think it's needed, but whatever. Let's try it. I think that's good. Okay, let's get out of here. Let's get on to Vim. Oh my goodness, we're getting Vim here. Look at this. I don't have Vim right now. Vim not found. This is gonna be a clip, I think. Let's see. So Vim not found. What we're gonna do now is install Vim by tarring it. And it's talking about how you can use, I guess, I don't know what this is, or this, but if you want to use one of these three, I guess you could. But Vim is what we're gonna use because it's obviously, you know, the king here. So let's get started with Vim here. I like how it's Vim 9 too. It's like Vim 9.1. That's good. Let's change the default location of the vimrc to be an Etsy. I'm cool with that. Let's configure that. Let's make that. Let's run the tests because Vim is important, I guess. We're gonna output this to the log here. All right, that test finished. Let's see if we can verify the output of that. There we go, 191 passes, 0 failures. So time to install Vim here. Many people use VI reflexively instead of Vim. So this part's for creating a symlink for VI to Vim. I'm not going to do that. Let's get the Vim documentation. So this is your vimrc. I'm not going to use this for my vimrc. I have my own vimrc. I'm going to grab that here. Oh, we have Vim, nice, okay. So I can do vim etsy vimrc. Yep, there we go. That's what we want. Cool. Well, we got Vim here, so. Go back down here. I don't think I need to explain what Vim is. You guys follow the channel, you definitely know what it is. Can move on to markup safe here. So let's get rid of that folder, clean that up. And let's tar markup safe. Let's install this here. This is a Python module that implements XML and HTML markup safe string. It's required for Jinja 2, the template engine, which I think is coming up next. And yes, it is. Let's get that. And we'll install that with the pip3 command here. This is used by Meson and other tools to generate files for the build process using templates. Okay, we need udev, and that's going to come from our system dtarball. So let's do tar xvf systemd2587.tar. Okay. And go into there. Remove 2 unneeded groups here with the sed command. Remove 1 udev rule. Adjust the hard-coded paths to work for the standalone udev installation. Let's make that directory for the build. And let's set that up with Meson. Let's install these. Let's get some custom rules here for the LFS environment and the man pages here. So we can update the database here, create the initial database here. And it looks like udev is complete. Udev is device manager that handles dev and device inputs, automatically creates device files and manages hardware without manual intervention needed. udevd is the daemon that it comes with. Let's move on to mandb here. All right, we can make this here. Run some tests. Everything passed. We can make install. Information here about the non-English languages here. Doesn't apply to me, but if it does, read this part, especially if you're looking for the Belarusian ones here. So man, we already know what man is, but we should have man now, so can we man it? Yep, we can man. We've got man pages. We've got man pages, so we're getting there. We're getting close to a working system here. I mean, this is pretty sick. Move on to procs. Make that and run some tests. There we go. We got all of them to pass. Make install. And there we go. We got procs. So this has pkill, pidof. This is pgrep, free. We now have access to free. So we type free. We see we've got 15 gigs of memory that's free. We got pgrep. So if we do pgrep screen, it'll tell us the PIDs of all of our screens here. PSAU. So this is all those tools to monitor your processes. PS, top. Actually, we have top now, I think, right? Let's check top. Yeah. So we got top. I mean, we're getting to a pretty built out system here. Let's move on to the utils. Let's get ready to compile here. Let's make it. We can ignore this warning here. It's just telling us that it's going to be harmful to our system if we run the test as root. That's okay, we're not going to do that. It's just going to run it as tester. So Util-linux is miscellaneous stuff like mount, fdisk, login, etc. We're going to need that to mount things, obviously. Mount partitions, what have you. And we can see if we scroll down, it's got more than just that. Column, eject, demessage. I mean, it's got a lot of stuff, just miscellaneous stuff, really. Kill, last, ls CPU. Looks like one test failed, and I think it's that same test that we're talking about here. It looks like the kill error is known to fail here. Yep, right here, it says it right there. So we're good, we can just make install. And we can get out of here. Move on to esprogs. E2progs rather. Let's move over to here. Let's make a build directory here. This is going to take, I don't know, actually, let's see. It says 2.4 SBUs on a spinning disk and then 0.5 on an SSD, but we don't know really what that means. So let's run make, and then let's run make check. It looks like it says there's a test known m assume storage is going to fail. So let's see if that fails. One test failed here. I can't see which one it is. Yep, there it is. M assume storage. Looks like we already know that's going to fail, so we're good to go. Make install, and then remove the static libraries. So E2FS keep going. gnzip, and let's install that system-wide. If desired, let's create things. Yes, we do want as much documentation as possible. Let's do that. I'm not going to worry about these errors here. So mkfs.ext4 is something that I always run when I create file systems. We don't have butterfs here though, but this is to make file systems and to debug file systems, etc. This is the E2FS progs. It's originally intended for ext2, but yeah, also supports ext3 and 4. Let's move on to syslog. This will be the logging messages here. Let's prepare for the compilation. Looks like we want to create a file here for syslog.conf. Now we've got a syslogger. So sysvinit is going to be our init system. So if you're a systemd hater, we've got sysvinit. Don't worry about it. So let's first get a patch going here that fixes the compiler warning. Let's run make, and there's no tests, so let's just make install. Power off, reboot, shutdown, etc. We have all access to all that. It's going to be good. And I think that's it for chapter 8. Yeah, debugging symbols, we don't need to worry about that. So stripping, this section is optional. If you want to strip, I recommend backing up your setup here before doing this, because I've stripped it in the past and I broke a Zlib library because of it. I'm not going to strip anything here because we're just going to move on to cleaning up. Let's get rid of everything in temp here. Let's get rid of all these libexec files. And get rid of all these unneeded stuff, and then we can delete tester. Okay, we don't even have it. So that's chapter 8. Chapter 8 done. We can move on to chapter 9. We're almost done here. We have a couple things here. We have 2 more chapters left, chapter 9 and 10. So we've got, oh my god, that was a long chapter. All right, so we've got system configuration and then making the LFS system bootable. So what we're going to do is go through chapter 9 here, a couple things we need to do to configure the system a little bit, and then making it bootable, which will be the Linux kernel, and then creating the FS tab, setting up grub, and then yeah, we're pretty much done. So let's jump into chapter 9. All right, so let's jump into chapter 9 here. We're going to be dealing with sysv init here. And let's look at some of these boot scripts here. Let's grab these here and let's just make install on these. All right. Good to go on that. So for overview of device handling, this gives you a history on kind of what's going on with udev. We're not going to be able to use this udev script at all because we are on a VM. We're on QEMU. But all it does is it renames enp1so to eth0, which we don't care about. We're just going to keep, as you can see here, QEMU. It doesn't work. We're just going to keep our interface name as enp1s0. So let's move on to the network configuration. And so for this file, instead of catting it, I mean, we could cat it for now. But hang on, let's do this. Let's cd to etc and sysconfig. And let's actually create this file. But before I run that, I need to figure out what my IP address is. Okay, it's 192.168.122. So that's fine. So what we're going to do for this is we are going to, my interface is enp1s0. So you guys need to figure out what your interface name is. And then you're going to do, well, let's do it like this. Vim to create the file, ifconfig.enp1s0 for me. For you guys, it might be eth0. It might be eth0. And we're going to copy all of this, but change all of it. So this is going to be enp1s0. The IP is actually going to be 192.168.122. Put 101 for now, doesn't matter. The gateway is 122, we saw that earlier. The prefix is 24, and then this is going to be 122.255. But let's confirm that. 57 is the IP address, but that's okay. So to confirm that this IP address is available, just ping it. I went ahead and pinged it and I found it is available, unreachable. But yeah, make sure your IP address is available, and then you can find this information by checking your IP address on your router on a different machine. So I've already checked mine, mine looks good. So let's get into that resolve.conf file. Now, I'm gonna keep mine pretty minimal here. I'm actually going to change this to, I'm actually not going to include a domain here. Actually, it's not needed. Just keep this super minimal here. Just put Google in there and then put 1.1.1.1 in there. So this is super minimal. We don't need to worry about the domain name. I don't care. For the host name, let's do LFS BTW because I use LFS, by the way. And then for Etsy hosts, I'm also going to keep this minimal. So let's take this as boilerplate, but like we're going to minimalize this a little bit. So let's do localhost there. This one's going to be LFS BTW, and then we can get rid of that, get rid of that. So it's just going to be localhost. Super minimal. That's going to work for me, for my situation. Should work for you as well. Just change your host name accordingly. And we're ready to move on to SV init. So let's create this init tab file, and it can be just exactly like this. And then we want to configure the hardware clock, but we can leave UTC as 1 since we are on Linux only. If you're on Windows, potentially you may want to switch that, but we're not going to dual boot here. So we can just leave that as it is, default. And then we need to run, we're on UTF-8 here, so let's create this console file. Unicode 1 is fine for us. For you, if you're not on US EN UTF-8, you may need to swap this out. This is for non-English here. You got to look at this as a potential guidance. And that's it. The rest is optional. So we can move into creating the locales. So let's run locale-a to list everything. Let's pipe that into less. And mine is en_us.utf8. So for that, we don't actually need the ISO. So what I'm going to do is just take this file and tinker it a little bit from my settings. Oops, we don't have the open. Well, so for this, I do want to swap a couple things out here. Let's do lang enus.utf8. And that's about all we need for profile. For you guys, you need to, if you're not on the en_utf8 locale, you need to find what your locale name is. And here's what you need to do. You need to run lcall equals ngb. For example, if you're in Great Britain, and then locale and then char map, and that's going to print the ISO, and then you need to put the ISO after UTF-8. Instead of UTF-8, you need to put ENGB. Right here, you're going to need to put the ISO. So ISO 8859 EN_GB. So that's how you would do that if you're not on the EN_US UTF-8. So that's kind of where we're at now. And I think we can put this, yep. Okay, so I think we can put these files in the input RC file. It's a generic file, so let's grab that. And then we also need the shells file, also pretty generic, but it's going to tell us that we have access to bash and sh. So if we want to change our shell, we can, but that's all she wrote for chapter 9. So we're going to move on to chapter 10, and this is how to make LFS bootable. So we need to create the FS tab here, and then install and compile the kernel, and then use grep to set up the boot process. So let's look at that here. This is the FS tab. So this situation is basically going to be determined by a couple of variables here. Let's lsblk. So I have VDA1, VDA2, VDA3, and I'm not going to put the UUIDs here. I'm just going to use the names. But yeah, this is a good default FS tab to work with, and then just change whatever you need accordingly. Now I actually have already set up my FS tab here.
based on my system. So I will copy paste that in. Now I can vim it. For this situation here, I am on a mount partition here for VDA3, and then boot EFI is vfat with defaults, and that's the second boot order, and then the swap is VDA2. The rest of it came from this file, and then, yeah, so it's exactly this file, but I changed VDA2, VDA1, VDA3, etc. because that's what you need to do for your system. So what I did in the beginning, if you followed me, you probably did SDA3, SDA1, SDA2. You can copy this from the written guide and just swap out VDA with SDA, or keep VDA if that's what your LSBLK says. But yeah, that's how that's gonna work. And that's the FS tab. So we can move on to the kernel. This is the hardest part now. So let's move on to the kernel here. So let's go back into sources. And let's untar this kernel. Let's move into that kernel folder here. And let's run make mr proper. And let's make a def config here, make def config for a default config. Now I could go line by line on this kernel and show you guys what I would do, but the problem is that my system is gonna be a lot different than your hardware. So I'm just gonna show the very defaults that are needed to get it up and running. I encourage you to tinker with it as needed, but we're gonna look at this as a guide here and kind of just set up what they have set up here. Now, this is where I'm gonna go into two different terminals. So let's go ahead and do that. So now I can full screen this and refresh this page here. Okay. A couple things we need to take a look at here. Let's run make menu config here. And that'll get us this menu. So the first thing we want to do is go into general setup and turn off compile the kernel with warnings as errors. So general setup, we want to turn this off. So N, and then we want to go into CPU task time and accounting. Turn on pressure stall information. I don't see CPU. Here it is. We want to turn on pressure stall information tracking and leave that off. Okay, perfect. Now we go into enable kernel headers, leave that off. Control group support on, memory allocator, memory controller on, configure standard kernel features. We can turn that off. It's already off, okay. So we can go back here now and go into processor, build, type in features, turn on build and relocatable kernel. That's already on, I think, but let's check here. There it is. It's on, keep that on, and then randomize the address of the kernel image. That's on as well. So that's good. Generic architecture dependent options, stack protector buffer overflow detection on, and then strong stack protector on. Okay, so device drivers. So let's go to device drivers, generic driver options. Support for unit off, maintain and auto mount for dev. Okay, so maintain on, auto mount on, firmware drivers. Okay, so we can go back. Firmware drivers. Mark VGA, VBA as generic frame buffer. Where is that? Okay, so turn this one on. Graphics support. Where's that? That's here. We need direct rendering manager. That's on. Then we need display a user for panic. We need that on. Where's that? Let's turn that on here. Support DRM clients. Enable legacy FDBEV support for your mod setting. Yes, we want that on. Simple frame buffer driver. We want that on as well. So that's on. Console display driver support. We want Verdio. I need to put all this Verdio stuff on too, by the way. but that's already on, so that's fine. Okay, console, display driver support. Where is that? Frame buffer console. That's on already. Perfect. So go back here. Additional stuff. So processor, let's go back to processor typed. We need to do X2 APIC, that's on, perfect. And then device drivers. PCI support, so let's go to PCI support. PCI support is on. Message signaled interrupts, where's that? That's on. IOMU hardware support. I think that's the one that got me last time. There, that's on. That's actually on. So support for interrupt remapping, IRQ remapping. That's right here. That's what gotcha. And then let's turn this Vertio IOMU driver on. We don't really need to worry about this, but we can turn it on anyway. Device drivers, it doesn't matter, right? NVMe support. So if you have an NVMe drive, you want to turn all this stuff on, or at least this one on. And then express block path, so turn that one on. Now, we need to go to this page here to look at a couple things. Okay, so we actually are on UEFI, so for Grep, we need to enable these. So EFI stub, it's processor type. That's on. That's on. And then enable the block layer. Where is that? That's here. So advanced partition selection. Otherwise we will not be able to boot. This is the most important one here. Where is this? Partition types. Yeah, we need to turn this on. And then EFI GUID partition support. That's on. Perfect. Okay, now file systems. We need to worry about that now. For file systems, it's going to be here. And then we need to make sure that the DOS FAT, we could turn that on, doesn't matter, but we have to turn that on here. DOS FAT, XFAT, where's that? I mean, that's on, right? VFAT. Okay, so we need VFAT. It's on. Okay. Okay, pseudo file systems, EFI variable system. M should be okay, but let's just turn it on. Native language support. Code page, United States, Canada. That's on. And then NLS ISO 8859 for the Western language. That's on. Okay, so that should cover boot. That should cover everything actually. And then the last couple of things I want to do is check for vert.io here. So let me go do that. So I need to check vert.io. Let me search something more generic, more specific. Vert.io BLK. That's on. Okay, I need also vert.io net. That's on. Vert.io PCI. That's on. That's all on. Perfect. And then that's the README. Okay. And then one more thing. SCSI vert.io. That's on. Okay, good. So I think that's correct. So let's hope that works. We're going to save that and exit and go back to this kernel here. The page, we have to run make and then make modules install. So this could take a while actually because we're making the kernel. This is the hardest part of LFS, is to make the kernel and make sure it's bootable. The final boss, if you will. So we're going to run this make modules install here. That's right, it's going to be in boot. And then let's get that system map. Let's copy our config file over. And then let's get the documentation. So we need to run chown-r 0.0 on /linux. We can skip this mod probe since we didn't do anything with USB ports, and I think we're good to move on to Grep here. So for Grep, we are using the BLFS version of Grep, so let's go here again. I have installed Grep over 100 times, so I'm going to do it this way. Yeah, we're gonna do a minimal config here. We don't need to worry about creating an emergency boot disk. We know the file partition is gonna be VDA1. We don't need to make this directory. We already have it set up in our FS tab. That's already set up in our FS tab. So we can install it like this, but let's mount the EFI vars first. This is the first thing we actually need to do. And then we want to put the EFI vars into our FS tab so that they load up on boot. Just run this straight, I think. And there we go. Look at that, no issues. Let's test this. And there we go. Perfect. That is what we want. That's our LFS file system. So for this situation, we're going to copy this exact config, but we're going to test it a little bit. We're going to move around some stuff. So vim boot grub.cfg. Actually, that's not where it went. Did I hit enter here? Okay, so, I just said at. Okay, that'll happen. It makes me scared that I did that for something else too, but whatever. For this, let's see, that's going to be HD03. It's going to be our VDA3. This will be VDA3 for our root partition. And everything else is good. So I think we're set up here. We're close to done here. There's one more thing we got to do. Let's get out of this screen because we do need to install one more thing. It's kind of important. And it is BLFS, so let's go figure that out real quick. We're gonna go to fast fetch here. And we're gonna go to the releases. And we're gonna get that AMD 64 tar.gz file here. Copy that link. And back into root on BLFS, let's do a wget. And let's tar that. So we have this binary for the fast fetch. We're going to want to put that into, here, let's CP this fast fetch binary and let's put that into mnt lfs user bin. So now we should have it in there. So screen-r lfs. I'm not going to run it yet because I want to see if, I just want to make sure we have it. But I'll ls user bin grep fast. We got it. Okay. And I think wget would be nice to have, but that's also extra BLFS stuff that we're not going to worry about. But I think in theory, we should be able to reboot. And if this just works off the rip, then yeah, 17 hours of configuring and testing would be kind of insane. So let's test it and see if it works off the rip. We should be good to reboot now. And just kind of pray, I guess. So let's see what happens. All right, so I have rebooted here and we see grub, which is a good sign. Oh my God, and there we go. It just worked straight up. Okay, that's incredible. Wow. So it's root and we have that super secure password. And we're actually into our LFS system. So yeah, I mean, if you've stuck along this far, I do have to say thank you for checking out the video. This was a long one, and I appreciate everybody supporting me here for the 10K subscription special. We're going to do some more stuff with Beyond LFS for maybe a 25K subscriber special, but this took so long to record and edit that let's see what happens when we get there. But yeah, as usual, drop a comment if you would like to see any more Linux content or any free and open source software content, and I'll put it in the pipeline. And as always, this would not be a proper ending without an obligatory neofetch.